Okay, guys, we are gonna walk through something called completing the square, and we're gonna break this up into like really two pieces, but I'll add a third video on for like the really extra case. Okay, so the big two pieces are there is the skill, a technique called completing the square, which we're gonna practice in this video, and I'm gonna keep these cases to the like easiest case. And in the next video, we're going to talk about how we use the skill as a way to solve quadratic equations, okay? So this video, just how do we complete the square? Next video, how do we solve equations using that completing the square quiz? Pardon me, I've got hiccups, and I'm not going to edit it out. Okay, so what happens is we're going to start with the first two terms of a polynomial, and for these cases, we're just going to have x squareds. So I have 1x squared plus a certain number of other x's, let's say plus 8x. Completing the squares, what happens? What would I need to add to those first two terms? What constant could I add so that I end up with a trinomial that when I factor it becomes a perfect square, okay? So first things first, we are always going to add a third term, okay? It doesn't matter if, hang on. Sorry about that, I had to refresh my memory on something. Okay, so it doesn't matter if this sign is a plus or a minus, and in the next example, it'll be a minus. This third term is always gonna be plus some constant, okay? So here's how we're gonna think through this. I'm gonna draw my thoughts on the screen. I'm gonna start by looking at that plus 8 right there. And in my head, I'm gonna ask myself, what is half of that number? So half of a positive 8 is a positive 4, okay? So that's an intermediate number. And then, to make it relevant back to this, I'm gonna take that positive 4 number and I'm gonna square it. I'm gonna multiply it by itself. So if I take 4 times 4, I get 16. And that's kind of like the first two steps in the completing the square process. In our heads, we're gonna take half of that b term, that 8, half of 8 is 4, and then the second step is square that. 4 squared is 16, and that's the value we add to complete the square. Now, why is that a perfect square? Well, let's factor it next. So I'm gonna approach this in a slightly different way than I normally do factoring in my videos, just for time's sake. I'm gonna think to myself, this trinomial is probably gonna factor as a binomial times a binomial. So first term times first term is going to get me that x squared. And the only real two things I can multiply together to get x squared are really x times x. So I'm going to fill this in with an x and an x there and there. And then I'm going to do a similar thought. I'm going to ask myself, what two numbers can I multiply together last times last to get me this positive 16? Well, it could be 1 and 16, it could be 2 and 8, or it could be 4 and 4. Give or take some positives or negatives. All right? So out of those three pairs, 1 and 16, 2 and 8, and 4 and 4, which one of those add up to give me positive 8? Well, it would be 4 and 4, positive 4 and positive 4. So I'm going to do plus 4 and plus 4. And you can check me. And I'm not going to write it out to keep the work here clean, but x times x would be the x squared. X times 4 would be 4x. The other 4 times the other x would also be 4x. 4x plus the other 4x is 8x. And then 4 times 4 is 16. So I've got it factored, but I notice here, these two factors are identical. And so when I multiply something times itself, I can think of that thing being squared. So I have x plus 4 squared. Okay? So let's talk through this, because one of the things that students sometimes have trouble with in the homework is some of the vocabulary. So So vocabulary-wise, what is that green 16? This is the value that I added to complete the square. So these three terms here, including the 16, this is the resulting trinomial or the resulting polynomial. And when I rewrite this in its factored form, what do I get? I get this x plus 4 squared. Okay? So let's do this a couple more times. What if this time I had x squared minus 20x plus what would complete that square? So in my head, I'm going to take half of that number. Half of a minus 20 is a minus 10. And then when I square that, negative 10 times negative 10 is a positive 100. So 100 is the number that I can add to the first two terms to make this a perfect square. Let's verify that. Let's factor it. So thinking the same way, what times itself? First terms are going to give me my x squared. X times x gets me x squared. Then what numbers can I multiply together to get a positive 100? Boy, it's a lot of numbers. In fact, let me make a list of it. So, hang on, let me pause. Sorry, I just had to add a different color to my template. The last color I had available was yellow, and that doesn't work really well. Okay, so what two numbers can I multiply together to get 100? Well, it could be 1 times 100, 2 times 50, 4 times 25. Let's see. 5 times 20, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 times 10, and I see here that these match up, so any other bigger numbers would be like 20, 25, I've got them all, okay? So out of these 5 pairs of factors, which ones can I multiply together to get 100, of course, but this time add up to get a negative 20. Well, in order for them to add up, then that means all of these pairs of factors had to be negative, but y'all probably beat me to it. It's going to have to be a negative 10 and a negative 10. So if I have x minus 10 times x minus 10, let's mentally check that. X times x is x squared, minus 10x's, minus another 10x's is minus 20x, and negative 10 times negative 10 is positive 100. So when we've got it factored, what do we end up with? We end up with x minus 10 times itself, which is x minus 10 squared. Now we're going to do a couple more examples, but maybe it's worth pointing something out. I hope you can hear me whispering. This is a really cheesy fact. I'm going to stop whispering. Okay. The thing that I want to sort of point out, if you hadn't noticed it yet, is 16 on this first example was the value that I added to complete the square. And when I factored it, I ended up with x plus 4 squared. So the 16 doesn't really appear here, but this plus 4 did appear in our head right here, right? It wasn't written in any of these terms, but we did have a positive 4 in our head because that was half of positive 8. All right, did the same thing happen on this example? 100 is the value that we added to complete the square, but when I rewrite that polynomial, the resulting polynomial in factored form, I get x minus 10. Is that minus 10 the same number I had in my head right here? Looks like it. That was probably just a coincidence though, right? Probably. Probably not. Okay, so let's do one more. Let me get you started. And then I'm going to have you pause it and see if you can figure out what was the value that you needed to add to complete the square. All right, so if I had x squared minus 14x, if those are the first two terms of a polynomial, what would the third constant term need to be that I need to add to complete the square? Okay, pause it and come back when you think you've got it. Okay, half of minus 14 should be a minus 7, and when I take a negative 7 and I square it, I get a positive 49. All right, if you didn't get that, then you did it wrong, and you should have done it the way I did it. All right, then, once again, pause the video and try to factor it out and see, do you get a perfect square, a binomial squared in its factored form? Okay, the only pairs of factors of 49 are 1 and 49 or 7 and 7. Negative 7 plus negative 7 adds up to negative 14. And so, in its final factored form, we do in fact get x minus 7 times itself, x minus 7 squared. Okay? So, on the next slide, let me give you just like a few more examples that I'm not even going to hardly talk through, just for you to practice. Okay, so here are 4 examples. First, try to find the constant term that you would need to add to complete the square, the number that we were doing in green, and then go ahead and factor it. Pause it here in a moment, and then when you have it unpaused, I will have all 4 answers written down for you. There we go. So, in green, your homework, this is the value that we add to complete the square. Value added to complete the square. That's my artist rendition. Then the left side, this is the resulting trinomial. Pardon my handwriting. And this is the factored result. Oops, misspelled result. Spelled it right in the end though. Okay. If you guys hadn't noticed, something else that's worth pointing out, inside the factored form of the binomial, whether I have a plus or minus here, is always going to be the same as whether I have a plus or minus on the second term. Okay, the other thing that I'm going to point out right now is this skill works the simplest and the easiest when I have just 1x squared and an even number of x's here. If I don't have 1x squared, or if I have an odd number of x's here, then these numbers aren't nearly so nice and pretty in most cases, okay? I'm gonna save all that for the third video in this series, if you guys want to, okay? But when it's me and I'm like alone in my house, I only do this skill completing the square under these conditions anyway. If I have 1x squared and an even number of x's. All right?